Alright, we're going to use the graphing method to solve the system, x minus y equals 5 and 2x minus y equals 6. Alright, so here is the method. Graph each line separately, one at a time. Maybe I'll say that. One at a time on the same set of axes. Whoops, what's that doing there? Okay, it's good if you have graph paper because this is not going to be quite as exact. So how do we graph it? Well, it doesn't matter. You can use slope-intercept form, you could make a list of ordered pairs, you could use the x and y intercepts. All right, I'm going to first graph line 1, x minus y equals 5. And I'm going to use the x and y intercept method myself, because that seems easy. So like if y is 0, x is 5. So I know 5, 0 is one ordered pair. And let's see, if I put in 0 for x, y would have to be negative 5. So this would be down here. And I can connect the dots. Now you may have solved this differently. You may have written y equals x minus 5 after you solve for x, graphed the y-intercept, did the slope of 1, you would get exactly the same graph. So this is the graph, x minus y equals 5, right here. Now let's do this other one in purple so it's easy to, or let's do green. All right, so we're going to graph that one. In green, I'm going to use the x and y-intercept methods here. Also, if I put in 0 for y, then x is going to be 3. So I know 3, 0 is on this graph. And let's see, if I put in 0 for x, I'm going to get y is negative 6. Okay, so I've got 3, 0, I've got 0, negative 6, so it's way down here. And then I have to connect the dots very carefully here. It's going to be hard. I think it's going to go through there. And you can see why you'd want graph paper, but it looks like maybe it's right here. I'm not sure, but it looks like that is at 1, negative 4. But I'm not sure. So I'm going to plug in 1, negative 4 into each of the original equations and see if it works. If it is, then I've got the right thing even though I wasn't so accurate. You can see why you want to have real graph paper and a straight edge. All right, so let's just check. And before that, explain what do we do. After we graph each line one at a time on the same set of axes, what do we just do? Find the point of intersection. That's the important part. Or actually, I should say it. The point of intersection is the solution. Okay, the point of intersection is the solution. All right, so that's the really important part of using the graphing method. The reason you graph it is because you need to look for the point of intersection. And then the last thing I'm going to do is check and make sure. I think it's 1, negative 4. So I'm going to first check it in x minus y equals 5 by putting in 1 for x, negative 4 for y, and does that equal 5? And it does. All right, so I check the first equation. If I call this equation A and this equation B, okay, so I checked it in equation A, and now let's check it in equation B. 2x minus y equals 6. Again, I'm going to plug in 1 and negative 4. So 2 times 1 minus negative 4 equals 6. That's also true because that gives me 2 plus 4. So I did pick the right solution from the graph. So the answer is 1, negative 4. And this is how what I have highlighted in yellow here is how we use the graph to find the solution to the problem. All right, number 2 is to solve the same system but use the substitution or addition method. It doesn't matter which method you use. I think I will use the substitution method. So what I'm going to do is solve for one of the variables. And I'm going to take this first equation here and solve for x. Now, there are many ways to solve this problem. Keep that in mind, but this is one way. So x is the same thing as y plus 5. So I'm going to go and put that in for x into the other equation, right? That's how the substitution method works. So instead of x, I'm going to put in y plus 5. Make sure you use parentheses. And now we have an equation with one variable. So we simplify the left-hand side doing the distributive property first, and then combining like terms. 2y minus y is y, plus 10 is 6. Then I'll subtract 10 from both sides, so y is negative 4. All right, so what does that tell me? For my ordered pair, the y value is negative 4. Now I want to take that y value of negative 4, I want to plug it in to the y up here so that I can figure out what x equals. So then, moving this over, x equals negative 4 plus 5, so x equals 1. So now I'm going to take that value and put it here. And there's my solution. That's the same solution we got graphically, right? Let's look back. Yep, 1, negative 4. It was the same two equations, but I did it graphically and got a solution of 1, negative 4. And I've already checked it, so I'm not going to check it again. So 1, negative 4 is the solution. You could do this by solving for one of the other variables or out of a different equation, or you could do this using the addition method. But I'm going to use the addition method on the next problem. All right, for this problem we're asked to use the addition method to solve. So I need to multiply one or both equations by something so that the coefficients of either the x terms or the y terms are opposites. So right now I see that the x terms have one of is a negative and one is a positive, so I'm going to eliminate the x terms. So I have to think what number both 2 and 3 go into, and that would be 6, right? So I need to multiply the top by 3 to get a negative 6 and the bottom equation by 2 to get a positive 6. All right, so you're trying to find out what you could multiply each equation by so you'll have opposite coefficients for one of the variables. All right, now remember, you're multiplying both sides of the equation by 3. So both terms on the left side plus the term on the right side by 3. So 3 times negative 2x is negative 6x. 3 times 3y is plus 9y. And 3 times 10 is 30. Second equation, we're going to multiply by 2 on both sides of the equation. 2 times 3x is 6x. 2 times 4y is plus 8y. And 2 times 2 is 4. Forgot the equal sign. All right, now, we did this so that when we add the two equations, we made it so that the x terms add to 0. So when I add the left-hand side, I just get 17y, and the right side adds up to 34. Divide both sides by 17, and I get that y is 2. So that tells me I know the y coordinate of my solution is 2. So we know y is 2. We want to plug that into one of these original equations, either negative 2x plus 3y is 10, or 3x plus 4y is 2. It does not matter which equation you plug it in. I'm going to go ahead and plug it into the second equation. So I'm plugging in 2 for y, okay? So this gives me 3x plus 8 is 2. Subtract 8 from both sides. Divide both sides by 3. And now you've got that x is negative 2. So now we also know the x coordinate. So this is our solution, which of course we're going to check and make sure it really is a solution to each of the original equations. All right, so we're going to make sure that negative 2, 2 is a solution of the first equation. So here's the first equation. We're going to plug in negative 2 for x and positive 2 for y and simplify the left-hand side. 4 plus 6 is 10. Right-hand side is already simplified, so yes, negative 2, 2 is a solution to that equation. And we're going to go over here, plug in negative 2 for x, positive 2 for y, and again we're going to simplify. Negative 6 plus 8 is 2, right side is 2, so it checks. So therefore, I was correct. Negative 2, 2 is the solution for this problem. All right, here's our last problem. 4 dresses and 3 hats cost $120, $29. 2 dresses and 1 hat costs $59. Find the cost of each. All right, so we've got to set up some variables. We're trying to find the cost of 1 dress and 1 hat. How about x be the cost of a dress? And y is the cost of 1 hat. Then it says 4 dresses and 3 hats cost $120. Well, 4 dresses would be 4 times x, right? The cost of each dress is x, so 4 times x plus 3 hats, that'll be 3y. That is going to be $129. All right, we also know that 2 dresses and 1 hat cost $59. So 2 dresses, that would be 2x, and 1 hat, that'll be y, equals $59. So now we have a system of equations, and we can either use the elimination, the addition method, or the substitution method to solve this. I think I'm going to use the addition method by multiplying the bottom equation by negative 2. That way I'll have a negative 4x and a positive 4x, okay? Now, there are many ways to solve this. I'm just showing you one method. So 4x plus 3y equals 129. And at the bottom, I got to multiply all the terms on each side by negative 2. So negative 2 times 2x is negative 4x. Negative 2 times y is negative 2y. And negative 2 times 59 is a negative 118. So it equals negative 118. All right, so this is kind of cool. On the left-hand side, when I add both sides, I just get y. So I'm going to be able to solve for y pretty quickly. 129 minus 118 is, let's see, is that 11? Maybe that's just 11. What was y? That was the cost of the hat. So the cost of a hat right here will be $11 if I did that right. Okay? Now I need to find the cost of a dress. So since we know what y is, we could plug that into any of the equations. I'm going to plug it into this one, the 2x plus y equals 59. So I'm going to plug in 11 for my y. Okay? So I have 2x plus 11 equals 59. And now we just solve for x by subtracting 11 from both sides. And then we'll divide both sides by 2. Hopefully you could do that in your head. That's 24. So looks like the cost of a dress is $24. So 1 dress, 1 hat, that's how much each costs. Let's see if it's true. So let's just do a quick check from the original problem. All right, so here's our problem. 4 dresses and 3 hats cost $129. And we've come up with that 1 dress is $24 and a hat is $11. So how much would 4 dresses and 3 hats cost? Well, 4 dresses would be 4 times $24, right? Plus whatever that is, that's going to be added to the cost of 3 hats, which is $11. So that would give us $96 plus $33. I'm leaving off the dollar sign. But that would be $129, and it said it was $129, so that checks. All right. It also said that 2 dresses, how much are 2 dresses and 1 hat? Well, 2 dresses would be 2 times $24, plus 1 hat would just be $11. So I would get 48 plus 11, that's $59, and that checks because up here it says $59. So this is the answer. 1 dress costs $25, 1 hat costs $11.